Problem 20, the graph of f is shown in the interval -1, 4, and g of x is equal to the integral of f of t from 1 to x. First thing that I'm going to do in this problem is just to identify what we've got. Okay, first of all, if they ask me anything about g, I know that g is an integral, so it's going to be the area under the curve of f. So I'll just write that down first. Okay, if they ask me anything about g prime is going to be the derivative of this integral, so it will just actually be f. So we'll just look at f, or we'll just be looking at the curve. And then g double prime is going to be f prime, or the slope of the curve. So just keep that in mind as we are doing this problem. Okay, first of all, it's asking me to find g, which is an area under the curve. So to get g of -1, I'm going to find the area under the curve. I'm going to actually use what it gives me here. It's going to go from 1 to x. X in this case is -1 of f. I can't go from a positive to a negative, so I actually need to switch to go from -1 to 1, which is going to force my answer to be the opposite. Okay, so I want the area under the curve from -1 to 1. I notice that that is a half circle, which is 1/2 pi r squared. The radius of the circle is 1, so it will be 1/2 times pi times 1 squared. That will give me an answer of 1/2 pi. I do have this negative floating along here, so it needs to be -1/2 pi. Right, g of 1 is the area under the curve from 1 to 1. We're not covering any distance, so that area will be 0. Okay, g of 3 is the area under the curve from 1 to 3 of f. So if I'm looking at the area under the curve from 1 to 3, it's this part right here, which is a triangle. Area of a triangle is 1/2 times the base. The base of that triangle is 2 times the height. The height of that triangle is also 2. 1/2 times 2 times 2 is 2. The area is all underneath the x-axis, so this integral will actually be negative. Right? And then g of 4 is the area under the curve from 1 to 4. And if I'm calculating that, I already found the area from 1 to 3. That was -2. So now I'm just going to add on what my area is from 3 to 4. That is also a triangle. The area of that triangle will be 1/2 times the base. The base is 1 times the height. The height is 2. So that answer is 1. -2 plus 1 is -1. All right, part B, find g prime of 0, 1, and 2. We did put on the other page that g prime was actually just the curve. So if I'm finding g prime of 0, I'm just looking at 0. The curve is up at 1. G prime of 1, just look over at 1. The curve is at 0. And g prime of 2, if I go over to 2, is right here. The curve is at -2. All right, g double prime, we discussed that that's going to be the slope of the curve. So if I find the slope of the curve, or the derivative, at 2, so if I'm looking at 2, there's a sharp turn here, which means there's no slope, so my derivative does not exist at that spot. And then g double prime of 3, if I'm looking at x equals 3, it's right here. And so notice that this, I'm looking for the slope. This point is on a line, so I just need to find the slope of that line. I'm going to do it by doing rise over run. I noticed to get from this point to this point, I'd have to go up 4 over 2. So that would be up 4 over 2, so that has a slope of 2. All right, part D and E have to do with relative extrema and increasing and decreasing. That has to do with g prime, which we've already decided was just looking at the curve. So I'm going to make a g prime chart for this. So if I make a g prime chart, I'm looking at the curve. To get critical numbers, we just look at where does the derivative equal 0, which would be here, here, and here. We'll get -1, 1, and 3. I'm going to scribble out over here because my interval does not go over to that side. Between -1 and 1, my curve is above the x-axis, so g prime will be positive. Between 1 and 3, my curve is below the x-axis, so my derivative will be negative, and after 3, my curve is above the x-axis, so the derivative will be positive. So if I'm looking for relative extrema, first of all, at x equals 1, there will be a relative max, because g prime changes from positive to negative. Okay, and then at x equals 3, there will be a relative min, and that is because g prime changes from negative to positive. And we actually do need to describe both places if they're a max or a min. Okay, where's g increasing or decreasing? We basically can just look for where g prime is positive or negative. I can say g is increasing from -1 to 1, and then again from 3 to 4. and that's because g prime is positive. And then we could say that this function is decreasing from 1 to 3, and that is because g prime is negative. All right, last two parts here. This time we're talking about concave up and concave down in points of inflection. That has to do with g double prime, and we already found out on the front page that g double prime was the slope of the curve, so that's what we're going to be looking at to make our g double prime chart. So let's just look at the slopes of our curve are positive until I get to 0, and then they are negative all the way down till I get to 2. We don't care that there's something happening there, big whoop. And then they are positive for the whole rest of the way. So that's my g double prime chart. So if I want to know where g is concave up and down, we're going to have concave up from -1 to 0, and then from 2 to 4. Notice I'm not going to infinity, I'm stopping at the endpoints of my interval, and that would be because g double prime is positive. And then I've got concave down from 0 to 2, and that is because g double prime is negative. All right, find all points of inflection. As long as g double prime is changing sign, we've got points of inflection. So there are points of inflection at x equals 0 and x equals 2, and that is because g double prime is changing sign. And there we got it.